Greetings, math fans. Alright, so this is day 3 of chapter 1, and we're going to start out by talking a little bit about using your graphing calculator. So this is going to be using your graphing calculator. And specifically, I'm going to be using the TI-84. So it may change over the course of the years, but that should be it probably should be somewhat similar. All right. So the first thing is your calculator must be in degree mode. I cannot stress it enough. Degree mode. Okay. If it is not in degree mode, you could have all your answers wrong. You're going to cry. It's going to be sad. It's just not going to be a good thing. So let's pull up the 83. Actually, it's the 84 here now. And what you do is you want to hit mode. See this button right here next to the second button. Hit mode. And see right now, see it's in radian. So you want to cursor down here. You want to cursor over to degree. And it's flashing, but you want to hit enter. And that moves the solid over. It's still flashing, but it moves it over to degree. Okay, so that's the main thing you want to do here. And then you can quit out of here, second mode. It quits. And so let's take a look at a couple different things here. First of all, we're going to be using the degree keys. And what you want to do for that is you want to hit second apps, this apps key. So it's really you're hitting the angle key. And you can see underneath it, it says number 1 has the degree symbol. And then number 2 has the minute symbol. We're not using number 3. And number 4 is the DMS, the DUMS key. And the DMS key is to convert it to degrees, minutes, and seconds. So if it's already in a decimal and you want to convert it to degrees, minutes, seconds, it does it for you automatically. It was kind of nice. Nice little feature. Now some of you guys are going, well, Mr. Gross, where is the second symbol? How come you talk about degrees, minutes, and seconds. Where's the second symbols? Well, not quite sure why TI did this. I'm sure there's a reason for it. Somebody told me recently that's because of when you program, I guess for quotes, I don't know. But it would have been nice even if they could have put it in 2 different places, because I think logically you would have it in this spot here for degrees, minutes, and seconds. But where it's at is you need to hit alpha. So let's just quit out of here real quickly just to show you where stuff is. You hit alpha plus. Alpha plus does the seconds key. Okay? So again, you're going to hit, second apps gives you degrees, minutes, and to convert degrees, minutes, and seconds. And then alpha plus gives you the seconds key. All right. So let's just do an example here. If I give you guys 80 degrees minus 12 degrees, 13 minutes, 53 seconds. This is actually from day 2. And if you guys, you can look back at your answer, but let's just do this one. In fact, I'm going to look back at my answer right now, just so we can kind of prove that the calculator knows what it's doing. If you do this, remember you had to kind of make 80 degrees into 79 degrees, 60 minutes, and then 79 degrees, 59 minutes, 60 seconds, right? And then you could subtract. So our answer for this one came out to be 67 degrees, 46 minutes, 7 seconds. Okay? Well, let's check it with the graphing calculator here. Very exciting. 80 degrees. Oops, let's clear this out here. Okay, there we go. 80 degrees. Second, so degrees. Now, technically, if you don't have any minutes and seconds, you don't need to put the degree symbol in. I'm just going to put it in. It's fine. Okay, so minus 12 degrees, 13 minutes. It's a little bit of a process here. You can either cursor down to the 2 or you can hit just 2. And 53 seconds. Remember, you have to hit alpha plus. Okay? And then if I would hit enter right now, which I can, it's going to give me 67.768611111. All right? So that's great. And now what I want to do is convert it in degrees, minutes, and seconds. So I hit again second angle because I want to use the number 4 key, the DMS. And then it takes my answer and it converts it to degrees, minutes, and seconds. Watch it. Watch. Oh, look at that. That's so cool. 67 degrees, 46 minutes, 7 seconds. Now you could have done this all in one keystroke if you wanted. If you hit second enter brings back previous calculation, so I'm going to hit second enter again. Sometimes you can do cursor up if you have a newer operating system. You can just hit the up arrow, hit enter, and then retype stuff in. So I brought the second of this line back here, and then if I want to do it all in one keystroke, I could do that and just hit, after I type in 80 degrees minus that 12 degrees, 13 minutes, 53 seconds, I hit second angle, and again I can do 4. So this is all in one keystroke, and hit it, and you get 67, 46, 7. Okay? So anyway, that is pretty much using your graphing calculator. It's really pretty easy to to do that. So let's talk about a little bit about that's to convert in degrees, minutes, and seconds. How do you convert it? If I give you degrees, minutes, and seconds, how do you convert it to decimal? Okay, this is so easy. Let's just do a random example. If I said 53 degrees, 53 degrees, 15 minutes. And I want to convert that to decimal. Okay, you could pretty much ask your little 3-year-old brother to do this for you. You just need to tell your little 3-year-old brother to push the enter key. That's all you do. So if you have a 3-year-old brother, find him right now, okay, and say, little Joey, push the enter key, and your little 3-year-old kid brother would go, okay, and he would go like this, and you'd go, oh my gosh, it's converted to 53.25 degrees. Okay, it doesn't have the degree symbol on there, but it is in degrees. All right, so it's really easy. In order to convert to decimal, you literally just hit enter. You type in the degrees, minutes, and seconds in there, and you hit enter, and then it converts automatically to a decimal. Okay? If you want to go to the other way around, so let's say I want to convert that back to degrees, minutes, and seconds, I can hit second apps, 4, and that would convert it back into degrees, minutes, and seconds, 53, 15, 0. Okay? Very, very simple. So I want to talk a little bit about rounding now. So we can get rid of the calculator here. If I want to talk about rounding, first let's talk about rounding with degrees, minutes, and seconds. Okay, so rounding in degrees, minutes, and seconds. So basically, you guys know that if you're halfway, if I said like round to the nearest tenth and you're halfway, at 0.5 and higher, you round up, right? Well, it's a little bit different in minutes and seconds, because what's the half? If I have, what's halfway to a degree? How many minutes? Well, it's actually 30 minutes. 30 minutes is the halfway point. And that's also the halfway point to the next minute, right? If it's 30 seconds or above. So we don't go with 0.5, we actually go with 30 and above for minutes and seconds. So again, the halfway point is greater than or equal to 30 minutes or greater than or equal to 30 seconds, depending on what we're talking about, what to round. So in other words, if I have 25 degrees, 42 minutes, and I ask you to round to the nearest degree, don't look at the 42 and go, oh, gee, it's less than 0.5. There is no 0.5. It's 42 minutes. It's greater than 30 minutes, or greater than or equal to 30 minutes. That means that would be 26 degrees. So again, if I have 47 degrees, 25 minutes, 28 seconds, and I want to convert that to the nearest minute, that 28 is below 30, so you're just going to get 47 degrees, 25 minutes. Okay? If I round to the nearest degree, again, that's below 30, you would say 47 degrees. Okay? And so that's it with degrees, minutes, and seconds. I just want to review with you guys rounding normal decimals, because kids still have a difficult time with that. So rounding decimals. I don't know why kids still have a tough time with that. If I ask you to round to the nearest tenth, that's 0.1. Nearest hundredths is 0.01. Nearest thousandth is 0.001. Now, the way you kind of remember this is basically, if I write with the number 10, it's got 1 0. So that's why I round to one place. If I have 100, that's 2 places, so it's 2 decimal places, so it's 0.01. So if I say nearest hundredth, that means that's how many decimal places you're going to round to. You count the zeros. Count zeros. What sometimes people do is they count, like they say the nearest, hundredth, and they think it's 100, 100. It's 3 places. It's 2 places. Okay, nearest thousandth. Okay, again, 1,000 has 3 zeros, so that's why it's the nearest, the 3rd place. Okay, 10,000 would be 4 places, 100,000 5 places, etc. All right, but it's just, don't get that confused. You guys definitely need to know how to round. All right, so let's continue on here with it's a little bit more geometry, really. Vertical angles. So what can you guys tell me about vertical angles? Well, hopefully you remember from, even with proofs, when you're proving certain triangles are congruent or angles, whatever, you can tell me vertical angles are congruent, right? This is the congruent symbol, the equal to with the tilde on top. And so if I give you guys A, B, C, and D, and E is in the middle, and I said find the measure of angle AED. What does AED stand for? Automated external defibrillator, I believe. Okay, or something like that. So basically, remember, if I ask you to find AED, let's see, I need to put some measurements in here. How about 2x plus 10 and 4x minus 20? There we go. Much better if we have a couple of measurements in here. All right. Anyway, so we get 2x plus 10. Since they're equal, you just set them equal to each other. So 4x minus 20. And then if I solve here, I get 2x, bring it over, 2x equals 30, x equals 15. Now, again, if you guys write 15 as an answer, boo, you're going to lose points. They love doing that in the ACT. Make sure you plug it back in. Okay, so I'm asking for AED, so it'll be 2 times 15 plus 10. So 30 plus 10 is 40 diggity. And of course, if I put the 15 back in the other side too, better also equal 40 because they're equal. So 4 times 15, 60, 60 minus 20, 40 degrees. Okay, pretty easy. How many degrees in a triangle? Hopefully you guys all know this. 180 degrees in a triangle. So just a real simple one. ABC, and I have 2x here, and I have x here, and I have 3x here. And I say find the measure of angle A. Hey, how you doing? All right. So again, what you're doing is you're setting all these equal to 180. So 2x plus 3x plus x, 6x equals 180. So x equals 30. And then of course you need to find the measure of A. So it's 2 times 30, which is 60 diggity. Okay, pretty easy, pretty easy. Let's talk about parallel lines. Parallel lines look like this. They look just like that, but they're truly not parallel lines until you do what? Until you put little arrows on them. And then all of a sudden they are now symbols for parallel lines. Okay, so let's talk about some different, well, first of all, we got to draw this. That line, if you remember, is called a transversal. And so let's look at a couple angles here. If I look at these two angles, what do you call those? They're called alternate exterior, because they're on the outside of the transversals. Alternate exterior angles. Okay, if I draw them inside here, because they're alternating between each side of the transversal, that line that I drew, and those are called alternate interior angles. Okay, what can you tell me if those are, if those lines are parallel? What can you tell me about alternate exterior angles and alternate interior angles? You can tell me that they are congruent angles. Okay, pretty easy, right? Here's another transversal with some parallel lines. And what about these two angles right here? What do you call these angles? Anybody remember? We're kind of talking to the computer screen here, so the computer doesn't remember. These are called corresponding angles. So the corresponding angles are congruent. Okay, so far so good. And then we have these two, so same idea, but this guy right here and this guy right here. We also have this guy in here and this guy in here. So these are called same side exterior angles and interior angles. Okay. Well, now you can look at those. You can see like this one here, math fans. You can tell that that angle is like bigger than 90 degrees, and this one's smaller. So if you remember, you're either going to have angles that are congruent, or you're going to have angles that are what? That are supplementary, that they add up to 180 degrees. So a lot of times you can just tell by looking at it to see, gee, one angle is bigger than the other, or one's, you know, or they're the same. If they're the same, then you know it's, well, kind of. I mean, obviously it could be drawn, you know, real similar, but it just kind of, especially when they're not drawn similar, you can pretty much tell what it is if it's congruent or supplementary. In this case here, you can see they're not congruent. Even this guy right here, right, that and that are certainly not congruent. One's way bigger than 90, one's way smaller than 90. So you can tell me that same side exterior and same side interior angles are supplementary, right? Which means they equal 180 degrees if you add them up. Okay? So same side. They're on the same side of that transversal, and they're either exterior or interior angles. Okay, so we'll talk about similar triangles now. So with similar triangles, math fans, we have a nice, we'll draw some nice triangles here. So triangle ABC, easy as 1, 2, 3, and let's put a little symbol on here, and then DEF. Right, and if I said triangle ABC is similar, that little tilde is similar. The equal to and the tilde means congruent. Just the tilde means similar. So triangle ABC is similar to DEF. So what can you tell me about that? Because if I tell you these two triangles are similar, what can you tell me? Well, you should be able to tell me that the angles, the corresponding angles, so like angle A and D, B and E, and C and F. So I'm going to write here corresponding because I think that's a good word. Corresponding angles are congruent. Okay? And what can you tell me about the sides? Well, the sides, again, this is corresponding. Corresponding sides are proportional. Okay? They're proportional. Now this has to match up. Notice I did the A and the D match up, and the B and the E, right? They're both right angles, and the A and the D are just congruent angles. And then the C and the F, they're automatically going to be congruent. If you guys remember from back in the day when you took geometry, you had angle-angle similarity. So as long as you have two angles that are the same, the third angle's got to be automatically the same. It has to be, because you just subtracted both of them from 180, and they're going to give you the same value because the other two angles are congruent. Okay? All right, so let's do a nice little friendly example here. I'll draw two triangles. And I'm going to mark them appropriately so angles are congruent there, and these angles are congruent here. This is going to be 9, 12, and 15, and then this is going to be 6, 8, and X. Okay, so first of all, are these triangles similar? Yeah, they are, because they have two sets of angles that are congruent. So that means this automatically makes this congruent, right? Because of angle-angle similarity. So you can, because those angles are congruent, you can say these triangles are similar. Now, are the triangles congruent? Well, of course not. In fact, we don't know that, but I can even look at it now and tell you, well, the sides are 9 and 12, 1, 6, and 8, so of course they're not congruent. All right, but because they are similar, we can set up a proportion. So what we're going to do is we're going to couple ways to do this, but I always like to look at, this is triangle 1 over triangle 2. So I like to keep the one triangle on top. So I'm going to say 9 over 6. So again, this is triangle, if I label this as number 1 and this is number 2. So triangle number 1 is on top and triangle number 2 is on the bottom. Okay, so 9 over 6 equals, again, triangle 1 on top, so 15. Triangle 2 is the x. Okay, so that's the other side I'm looking at here. And then I just set up my proportion. So basically, if I wanted, I could actually reduce this ahead of time, which is kind of friendly, right? I can even say, this is, it's 3 goes into that 3 times 3 goes into that twice. Just kind of helps reduce it. So you get 3x is equal to 30, and x equals 10. And there we go. That's the measure of the side. Okay, it's pretty easy, right? Now, I personally think that proportional triangles actually come in really handy in life. Back in the day when I taught geometry, it was fun to go outside and kind of guess the height of the goalpost because of, because of the length of the shadows and everything. That's just like a really good application. I kind of look at a really good application is, you want to know how high your tree is in your yard because you want to buy a trimmer at Home Depot. And how high of a pole do you buy? Do you buy a 30-foot, a 40-foot, a 50-foot pole? It adds up adds to a lot of money if you're buying 10 extra feet and everything. And so how high is your or how long is the pole going to be? And you can use that by basically measuring your the height of the mailbox and its shadow, and then the shadow of the tree, and you can figure out how high the tree is. It's so cool. I love applications like that. All right, so let's do one here now. Application. So we have goal, post, casts, 75-foot, that's a scary monster, shadow, just kidding. Mr. X, we'll make it a little mysterious. Mr. X is 6 feet tall. And casts a 20-foot shadow. How tall is the goalpost? I like the word goal. Goal looks like go Al. I got a buddy of mine, Al. Go Al. Woo! Oh, sorry. Okay. How tall is a goalpost? So it's really easy. You're just setting up triangles here, math fans. And basically, we can say this is our goalpost, GP, and this is Mr. X. So the goalpost is cast a 75-foot shadow, and you want to know how high it is. And the Mr. X is 6 feet tall, and he casts a 20-foot shadow. Now this is a right angle because they're standing perpendicular to the ground. And then just the way the sun is shining down, because you measure at the same time, this is going to be congruent, and that means this is going to be congruent. And then it's really easy. Remember, I said keep like the goalpost stuff on top. And then, so that's x over 6, Mr. X is on the bottom, and 75 is the height of the goalpost, and 20 is Mr. X's. So on the bottom is Mr. X, on top is the goalpost. I cross multiply, I get 20x equals 450, I believe. Okay, and then divide by 20. So x comes out to be 22.5 feet. And guys, please don't forget your units. Okay, units. Move that up a little bit. Okay, do not forget your units. Okay, it's really important. In engineering, if you come to the board of directors and you're like, oh yeah, it's how much steel we need. Oh, we need about 10,000, and they're gonna be like 10,000 pounds, tons, metric tons, schmutzkis. They're not grams. They're not gonna have any idea what you're talking about. Gotta have units always, always, always in a problem. Very, very important. Okay, so this can be 22.5 feet. All right. One last problem here, math fans, and you've seen this problem before. It actually goes with similar triangles. If you get a triangle like this, so these are both perpendicular, and this is 8 inches, this is 5 inches, and this is 20 inches, that little part right, or the long part right here, 20 inches. And I asked you to find the height of that other triangle inside there. Okay, so basically, if you've seen this problem before, but what you could do if you wanted, that's the little triangle, and there's the big triangle. You can just break it up, because truly you have two similar triangles. And you're like, well, how is that similar, Mr. Curvis? Well, you have two angles here. Here's an angle and here's an angle, and you have a shared angle between both of them. That big triangle shares that angle, and the little triangle also shares that angle. So you have angle similarity, which means the sides are proportional, right? So I can label this as 8, that's the big triangle, and the whole thing is 25. And then the little one is x, and that little part is 20. So I'm going to do little over big. So I'm going to say x over 8 equals 20 over 25. Okay? Again, if I wanted, I could simplify 20 over 25. I can say that 5 goes into that 4 times, 5 goes into that 5 times, and then I can cross multiply. 5x equals 32. And I divide x equals 6.4. Again, it's inches. Units. Okay? So, you've seen this before, but it's a pretty easy problem. Just be careful, setting it up. I would say the most common mistake, which I always like to warn you guys about, most common mistake is people do this. I'm going to put this in red for danger. Do not do this. People go, oh, look at, okay, the big triangle, 8 over x, that's fine, equals, and then they do 5 over 20. Right? They just use this 5. They don't use the whole length. Boo! That's like a really, really bad mistake. Don't do that. Okay, bad. Good. All right, so anyway, that's it, math fans. Talking a little bit about the calculator, a little bit about vertical angles, parallel lines, similar triangles, and we're good to go. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.